Okay, for what we have, in section 8.4, we have a system of equations in x and y. And here we have y is equal to x squared plus 7x minus 5 for the first expression of y. And then we have, for the second equation, we also have expressed in terms of y, where we have is equal to 6x plus 7. And what we can do is one approach. Okay, we have with y equal to 6x plus 7 and y equal to x squared plus 7x minus 5. Okay, we have with section 8.4, we have for the first equation system, okay, we have y equal to x squared plus 7x minus 5, and we have y equal to 6x plus 7. And since both of these expressions are in terms of y, we can set each of the expressions we have y set equal, and we can just rewrite, saying we have x squared plus 7x minus 5 is equal to 6x plus 7, because we're looking at solving for the same x and y coexists as being both equal to x squared plus 7x minus 5, as well as 6x plus 7. So we have, in substituting, I can go ahead and solve for x. And here we have a quadratic equation. And if I combine like terms together, and I can write what I have in x as a quadratic equation, that will be in standard form. So we have in the rewrite, okay, so I have x squared plus x minus 12 is equal to 0. And for x squared plus x minus 12 equal to 0, so we're going to have a couple of expressions in x. So we have the quantity of x plus 4 times that of x minus 3 is equal to 0. And if x plus 4 is equal to 0, well, we have x equal to negative 4. If, on the other hand, I have x minus 3 equal to 0, well, I have that x is equal to 3. All right. And now, if you notice, you have two solutions in x. Now we'll be looking for the one solution for y for each part. Okay, so I have two solutions in x, and there will be two solutions in y. So just going back to what we have with y equal to 6x plus 7. If on the one hand, I had that x is equal to negative 4, and I had that y is equal to 6 times negative 4 plus 7, and with x at negative 4, we have y equal to negative 24 plus 7, and negative 24 plus 7 comes out to negative 17. Now we have, on the other hand, if x is equal to 3, it's going to follow that for y equal to 6x plus 7. We have y is equal to 6 times 3 plus 7. 6 times 3 is 18 plus 7. So we have that y is equal to 25. So we have a couple of solutions in the mix. So we have x is equal to negative 4. Y equals negative 17, and that we have x equal to 3, and while x is equal to 3, we have y equal to 25, and also we can say that bunching up as ordered pairs, we have negative 4, negative 17, as well as 3, 25. So those will be the 2 points upon which the graphs of both equations will intersect. All right. Now, for what we have in the case of the second system, we have x squared plus y squared is equal to 10. and we have y minus x is equal to negative 4. And let's say that just putting the second equation in terms of y. Okay, so I have y minus x equal to negative 4. And let's say that if I take the x term and add, so just rewriting what we have in the second equation, I can say that I have x is equal to, or I should say y is equal to x plus 4. And upon doing so, I can now substitute for y. And solve for x. So we'll have, in this particular case, right, so I have x squared. And I have plus x plus 4 quantity squared is equal to 10. And if I combine, okay, so I have x squared. And for the square of x plus 4, so I have x squared plus 8x plus 16 is equal to 10. And if I combine the variable terms, so I have 2x squared plus 8x. And I'll just go ahead and take away 10 from both sides. So we have 2x squared plus 8x plus 6 is equal to 0. And if I factor out 2, okay, and the 2 doesn't do anything for us, it's just a coefficient. However, for the variable factors, I have the quantity of x plus 3 and the quantity of x plus 1 equal to 0. And so we have with x plus 3 and x plus 1, if I set each of the factors equal to 0, if x plus 3 is equal to 0, I have x equal to negative 3. And if x plus 1 is equal to 0, I have x equal to negative 1. And going back to what we have for y, again we have y is equal to x plus 4. And if we have that x is negative 3 and that x is negative 1, so we have that y is equal to negative 3 plus 4, which is going to be 1. And we have that y, whenever x is at negative 1, is going to be negative 1 plus 4, which will come out to 3. So we're going to have for our system, we have x equal to negative 3, and y is equal to 1, and that x is equal to negative 1, and y is equal to 3. And you can also write as ordered pairs where we have negative 3, 1, and also negative 1, 3. And we have with the last system, and we have x squared minus 4y squared is equal to negative 1, and we have x squared plus y squared is equal to 19. And we can combine these equations by the addition method. If I adjust the, let's say, the second equation, and if I take the opposite sign of the second equation, so we have in the rewrite, have x squared minus 4y squared is equal to negative 11. And then we have taking the opposite sign of the second equation, have negative x squared minus y squared is equal to negative 19. And combining, have x squared and negative x squared go out. Negative 4y squared plus negative y squared becomes negative 5y squared. Negative 11 plus negative 19 comes out to negative 30. And we have, with division, y squared is equal to 6. And we're going to have that y is equal to plus or minus the square root of 6. Now, so you have two solutions in y. And if I go with the second equation, again, whereupon we have x squared plus y squared is equal to 19. And if I take what I have for y squared, for all of y squared, so I'm going to have that x squared plus 6 is equal to 19. And if I take 6 away from both sides, then we have the x squared is equal to 13. And we have, with the square root property of equality, we have that x is equal to plus or minus the square root of 13. So we have, in the case of the solutions, okay, all right, so we have x is equal to plus or minus the square root of 13. Y is equal to plus or minus the square root of 13. And for what we have as ordered pairs, let's say I have the square root of 13. And let me take this back. Y is equal to plus or minus the square root of 6. My apologies. Okay, so I have square root of 13, square root of 6. Also I have the square root of 13, and we have the negative of the square root of 6. And also we have the negative square root of 13, square root of 6. And we have, with the remainder, we have the negative of the square root of 13 and the negative of the square root of negative 6. So there'll be 4 points of intersection